Welcome to our series of short educational videos about important concepts of building performance. This video shows the principles of convective heat transfer in buildings. Convective heat transfer requires the movement of a fluid, either a liquid or gas. We show a simple process model that illustrates how convective heat transfer works. Let's look at it. Let us think of a conveyor belt which symbolizes the process of moving quantities of heat in the moving fluid. The object A is placed on one side of the conveyor belt. Heat is added to the object A until the object A reaches a thermal equilibrium with the source of the heat. By adding heat, the object A has increased its internal heat. We now move the object A with the conveyor belt from position 1 to position 2. Position 2 is the location where we can release the heat to a surrounding that is colder than the object A. Let's look at the simple animation again. We are now looking at several scenarios of convective heat transfer in buildings. This illustration shows warm outdoor air entering indoor interior spaces through unintentional openings in the envelope, such as cracks or construction or installation openings that have not been properly sealed. To lower the intrusion of warm air, the building envelope must be properly sealed. In this case, the warm air enters from the outside to the indoor space through intentional openings such as windows. In this illustration, the heat is transported with a working fluid from the inside space to the outside. This form of heat transfer by a fluid is essential for the working process of air conditioning. We can calculate the amount of heat transferred by a fluid with the following equation. Delta Q equals C times M times delta T, where delta Q is the amount of heat added to the fluid. C is the heat capacity of the fluid, also referred to as specific heat. Delta T is the temperature difference of the fluid before and after the heat was added. M is the mass of the fluid. The table shows us a comparison of how much heat must be added to eat the same amount of water, or the same mass of water, and air. As we can see, it takes 4 times as much heat energy to increase 10 pounds of water for 30 degrees Fahrenheit than it takes to heat 10 pounds of air for the same temperature. This indicates that water is a much more effective heat transport fluid than air, since the heat stored in water is much higher than in air. In this slide, we look at a practical application of transporting heat inside buildings. This illustrative example shows us the difference of heat moved by a flow of water and of air. For this case of heat transported by air, we take a typical case of a central air conditioning system where significant quantities of chilled air are circulated inside the conditioned space. The illustration shows a cross-section of an air duct, views of typical air ducts, and the required ventilation fan, which moves the air through the ducts. For the case of heat transported by water, we look at the chilled water moved through pipes. The image also shows elements of a so-called hydronic system, such as used for chilled beams and radiant ceilings. The comparison of both cases assumes the same amount of heat transported by either water or air. The illustrative comparison shows the required cross-section of the air duct and the water pipes, which would be required to transport the same assumed amount of heat. As one can see, air ducts as large as 48 by 24 inches would be needed compared to an approximately 1.5 inch diameter pipe to transport the same amount of heat. The required space for the indicated water pipes is significantly less than for the air ducts, shown in the figure. This makes installation of chilled water pipes much easier than air ducts. Moving large volumes of air requires much more fan power than moving water with pumps. We need to realize that the density of water is about 900 times the density of air. This means that 1 cubic foot of water weighs the same as 900 cubic feet of air. We now come to our self-learning assessment. Let's see how much you remember from our discussion. The self-assessment is an important step in the learning process. We can either contemplate and answer the questions ourselves, or you can discuss the questions with a good friend or colleagues. It is proven that the best way to learn a topic is to explain it to somebody else. You see several self-learning assessment questions below. Please try to answer them. You might want to review portions of this video. Thanks for trying. 1. What is a good illustration of the working principle of convective heat transport? 2. What is the main difference of heat transported between water and air? How does the heat transport differ between using chilled water pipes and AC air ducts? This concludes our video. Thank you for your interest. Please join us again for one of our other videos about important concepts of building performance.